Welcome to this short presentation on the new B.Tech course in Engineering and Computational Mechanics, which has been started by the Applied Mechanics Department at I.I.T Delhi. This is a 4-year B.Tech program with an annual intake of 40 students through JEE Advanced. When we started this course, we had a lot of consultations with prospective employers and members of the global academic community. And we came up with this broad-based interdisciplinary program. The contents of this program include courses in classical mechanics, including solid and fluid mechanics, analytical and experimental tools to solve mechanics problems, and then also a lot of stress has been laid on computational tools like finite element methods, computer-aided design, computational fluid dynamics. Design is also a part of this curriculum of this course. There's a course on digital electronics and a course on data structure and algorithms is also a part of the core of this curriculum. The newer branches in mechanics like biomechanics and multi-scale mechanics, which includes nanomechanics, will also be covered in the curriculum. And then there will also be a course on machine learning and artificial intelligence in mechanics. After a B.Tech in this course, where do the graduates go? There are excellent prospects for the students who graduate from this program to join graduate school in leading global university in a variety of disciplines like mechanics, mechanical engineering, computer science, biomechanics, etc. A lot of companies which hire graduates have also shown interest in hiring people from this discipline, and this would include software and computational companies like ANSYS, NVIDIA, Abacus, Google, research companies, companies in the aerospace area, automobile companies, consulting companies, technical consulting companies like Cummins, Bosch, Siemens, L&T, petroleum and oil companies. All of these would be prospective employers of the graduates of this course. The Department of Applied Mechanics has been a part of I.I.T Delhi since its inception, and it has offered M.Tech and PhD programs. But since its formation, we have been teaching undergraduate students of all disciplines, and the courses which we teach are mechanics, fluid mechanics, and solid mechanics. So undergraduate teaching has been an integral part of the ethos of the Applied Mechanics Department. And traditionally, the department has been known for excellent teaching, with many of our professors winning the Distinguished Teaching Award offered by I.I.T Delhi. Some of my colleagues will now talk a bit more aspects of the mechanics courses. Thank you.
Engineering mechanics can broadly be divided into solid and fluid mechanics. In solid mechanics, low deformation behavior and strength of solid materials is studied and used in design of structures. The properties of materials are often determined experimentally, and the structures are modeled using mathematical equations. These equations are either solved analytically or computationally. In the department, we look at many real-life systems and use computational tools extensively to solve these real-life systems. Solid mechanics finds application in automotive, aerospace, navy, biomedical industries, to name a few. The department has got excellent computing and experimental facilities, and students use these extensively to do projects. Some of the projects are shown here. One of the projects is on design of bulletproof jackets and optimizing its weight. Both experiments and numerical tools are used for this purpose. Another one is on designing a low-weight helmet and studying stresses in the brain with and without a helmet. Some other projects are shown here. One of the projects is on determining the properties of carbon-carbon composites used in the nose-tip material of a missile. The department has got X-ray tomography facilities, and these can be used to study porous materials such as trabecular bone. Fracture mechanics is used in studying snow avalanches. Both experiments and simulations are used in studying vibration of shells, and simulations have been used extensively in modeling the molding of glass lenses used in mobile cameras. With the B.Tech in Engineering and Computational Mechanics, you'll be able to do such problems easily.
Multi-scale mechanics is one of the focus areas of this program. Have a look at this diagram. Here we have a cylindrical specimen viewed from the naked eye. However, when you put it under a microscope, you start seeing its microstructure. For example, at micrometer scale, you will start seeing different grains in this material. Further down at nanometer scale, you start seeing the actual crystalline structure of each of the grains, which could be FCC or BCC or a simple crystal. It's the multi-scale mechanics which can tell you how the property, for example, the Young's modulus of the material is affected by the structures at different scale. Similarly, multi-scale mechanics could be used in designing new materials. For example, have a look at this diagram where we have plotted all existing materials with their density on the x-axis and Young's modulus on the y-axis. Now you see, there are this region where no materials exist. And in the aircraft industry, the challenge is to develop lightweight material which also have high strength or high Young's modulus. Now, can we engineer new materials so that they lie in this region? That will be a boon for the aircraft industry. You can also talk of mechanics of nanotubes. Now, how do you bend or twist a nanotube at molecular scale? How do you simulate a nanotube at continuum scale? Mechanics of DNA. Here you have a single molecule DNA adhered to the substrate, and at the other end it is being twisted through optical tweezer. This is, by the way, the real experiment. And as you twist this DNA through tweezer, it forms this plutonium shape. Now, can we simulate such shapes? Finally, have a look at this interesting locomotion of a single cell. Can we do its computer simulation? So yes, you can do it through multi-scale mechanics.
Biomechanics is an interdisciplinary application area of the fundamental principles of mechanics to study structure, function, and motion of biological systems at multiple length and time scale. Now, the size of the length scale can start from the molecular level, or where we talk about size scale at the sub-nanometer or the angstrom level. It can go up to a cellular scale level, where a typical cell is of the size of 5 micrometer to 30 micrometer. All the biomechanics can be studied at the tissue or organ scale level, where the sizes generally varies from the millimeter to centimeter level. To give you an example of the tissue level biomechanics, there are various areas like brain mechanics, cardiovascular mechanics, bone mechanics, the works are going on in the department. To give you specific examples, that there are groups in the department who have started working on the physics, mechanics, biomechanics of brain tissue, where the questions we ask generally, how the deformation physics of the brain tissues, can we estimate the deformational physics of the brain tissue? The idea is, if we can understand the damage mechanics of brain, can we create a virtual simulation platform where the surgeons can practice the surgery before actually doing the operation on the actual patient? That gives you kind of pre-planning opportunity. The advantage is that it reduces trauma, it reduces the mortality. To develop a simulation platform like this, we are also using newer technology like virtual reality, mixed reality platform. For real-time damage simulation, we need physics-driven AL and ML coupled with high-performance computation facility. The organism level biomechanics is generally applied at the length scale or the size scale level of meter. A typical human size, human body is of the length of meter scale level. To give you examples, some of the projects going on in the department is that how we want to study how the neurosignal or the brain signal controls the muscle movements, or how the device, external device or the wearable device affects the biomechanics of human motion. This there is a new called symbiotic biomechanics one. There are various courses existing in the department. You will be exposed to next over the next 4 years of stay. Please feel free to contact us if you need further information. Thank you.
Hello students, let's introduce you to the impact and shock research at our Impact Mechanics laboratory. Here we study the interaction of bullets and blast on the protective barriers. Research here not only explores the fundamental mechanics behind the high rate of loading but also save life. Following video shows a flat-face bullet impacting a steel sheet at 250 meters per second. I expect you to note that lightweight sheet fragment is traveling faster than the projectile itself. Interesting, isn't it?
Hello, my name is Amitabh Bhattacharya, and I am a faculty in the Fluid Mechanics group in the department. Over the past few centuries, researchers and engineers have been developing and utilizing theories based on fluid dynamics to solve a broad array of problems related to technological applications and natural phenomena. The equations of fluid dynamics are, however, quite complex and cannot be solved easily using pen and paper for most real-life applications. In computational fluid dynamics, or CFD, efficient, robust numerical algorithms are devised to evolve these equations on computers for different flow geometries. Results from CFD simulations in tandem with measurements from lab experiments can provide valuable insights on optimization of the flow dynamics. The faculty in our department are actively involved in building these CFD algorithms and developing computer codes to solve for fluid flow related to aerodynamics of vehicles and aircrafts, turbomachinery, geophysical fluid flows, wind energy, biological flows, and fluid structure interaction. The size of flow geometry can range from millimeters to many kilometers. The department is equipped with state-of-the-art computational facilities, including a CFD lab for students and access to institute high-performance computing facility. As part of the B.Tech core curriculum in Engineering and Computational Mechanics, students will be taught courses in thermodynamics, heat transfer, theoretical and computational fluid dynamics. The extensive curriculum on computational methods is especially unprecedented for an undergraduate engineering program. The analytical and computational skills taught in these courses are in high demand in several industries, especially the ones related to aerospace and automobile engineering. These skills will also equip the students to contribute to research groups in industry and academia.
The Department of Applied Mechanics is very active in experimental fluid mechanics. So, why do we need experimental fluid mechanics? There are no general solutions to the governing equations of fluid mechanics yet, and as my colleague Professor Amitabh had indicated, we can solve these equations using computers to any accuracy required, but a meaningful flow, say let's say over a bus at normal speeds, cannot be solved in a short time even using supercomputers. So a modeling effort is a must for realistic flows, otherwise we cannot solve any realistic flow in a reasonable time. We also need to understand the physics of unknown high intensity flows to be able to model them and to understand the flow themselves. And this is where experimental fluid mechanics comes in very strongly. At the Department of Applied Mechanics, we have several areas of research, and these are turbulent flows in wind turbines and turbine forms, industrial fluid mechanics, and fluid structure interaction. We have several facilities, state-of-the-art facilities. We have several low-speed wind tunnels to cater to a wide variety of flows. State-of-the-art diagnostics, hot wire anemometry, particle image velocimetry, and more traditional methods of flow measurement. We also have, most importantly, we also have the ability and infrastructure to set up a wide variety of advanced experiments. What does it all mean for a student? If you are a new B.Tech student, you will get a thorough grounding in the fundamentals of fluid mechanics in the coursework. You will get a solid introduction to experiments through projects. This will all enable you to sail through any job responsibility having fluid mechanics as its component after graduation.
In the wake of modern naval warfare strategy demanding high degree of stealth in design, the external geometry of frontline warships has undergone a paradigm shift. These changes in geometry have led to a higher turbulence in the halodeck region of the ships, which in turn have increased the complications for a naval pilot in handling of the helicopters. Also, the complex coupling of the halo downwash and the ship's airwake on halodeck have led to unfavorable variations in aerodynamic loading on the rotor blades, leading to difficulties in hovering over the moving deck. Several nations are conducting research to understand the halo operating environment on such ship forms using modern experimental and numerical techniques with an aim to arrive at innovative solutions for improving the halodeck design without compromising on stealth. In the Applied Mechanics Department of I.I.T. Delhi, investigations have been undertaken in the past few years using various experimental and numerical techniques, including flow visualization studies in wind tunnel and development of CFD model for analyzing the halodeck flow field. Applied Mechanics Department has become the nerve center for a large spectrum of research in aerodynamics of naval warships.
One of the unique features about the new B.Tech program on Engineering and Computational Mechanics resides in the fact that it brings classical mechanics and AI-based techniques together. If you look into the AI market, it has seen an unprecedented growth over the past few years, and it is expected that this growth will continue. If you go by the prediction of MarketWatch.com, the artificial intelligence market will increase from around $24 billion in 2018 to around $208 billion in 2025. Now that is an staggering compound annual growth rate of 36.2%. Now, if you are wondering what kind of problems in mechanics artificial intelligence can solve, well, the list is quite long. So let me give you just two examples. So Professor Amitabh was talking about flow field, flow around a blob body and all those things. Now, using artificial intelligence, you can extract useful features from this flow field. And this is extremely important. Professor Ajit was talking about discovering new materials, and AI can help you there. You can use AI to discover new materials with unique properties that are not found in the nature. So these are the problems you can solve by using AI. Now, if you are registering for this program, there are some useful courses that you will be taking, and this includes artificial intelligence, digital twin, parallel computing, and soft robotics. So the idea is to give an all-round training to the students registering for this program. We, the faculties of Applied Mechanics, I.I.T. Delhi, are committed towards preparing and training our students to be the future leaders through this program.